Good evening. Thanks for inviting me to spotlight Vehicle to Everything. My name's Steve Kale, so I'm part of the capacity products team at BC Hydro. Vehicle to Everything is part of my portfolio along with other technology pilots, and I've been working, at BC Hydro for 21 years and on V2G for 7 years. BC Hydro, we launched an energy storage incentive program in June last year. The program provides funding for customers to nominate a portion of their stored energy to feed customer loads during peak hours. This reduces the draw on the grid and takes pressure off. Now, we think the benefits of stationary storage can be provided by EVs in the near future, and this includes grid outages and weather emergencies, um, shaving the peak loads for bill savings, participation in grid programs to earn rewards, um, optimize panel capacity to share with other devices and appliances. So coming back to energy storage program launched last year, EVs can be a customer choice option along with the stationary storage unit. I think it's better because it's movable, but I'm slightly biased. We want more bi-directional charging from EVs. And, so when we talk about managed charging, so a managed charging strategy with bi-directional capability, that is, electric vehicles can take and give power strategically, right? Interacting directly with the grid or a home or building, that transforms the EV users from consumers to participants of the energy network and creates a new value stack for the EV owners, right? They're not just using the vehicle for transportation; they can use it for other things to bring benefits to their home, their business, and even their neighbors. Right. So this opportunity requires the vehicles to be connected, of course, right? And then the coordination can be orchestrated through dedicated channels. Um, Driven by localized or regional needs or through other market mechanisms like peak pricing or notifications. What Doug said earlier about V2X, right? There are acronyms to represent loads that can be connected to EVs. The umbrella that covers all the use cases is V2X, or vehicle to everything. So here are other short-term key applications for V2X technology with electric vehicles at the center, right? You have V2L, that's vehicle to load, like a heater or lights or cooler. Sometimes this can be done through a separate socket in the trunk and not necessarily through the EV charging port. And then there's V2H, vehicle to home. The power flows from the vehicle charging port through the bidirectional capable charger into the house panel. Therefore, thereby allowing a house to continue to operate during an outage or something like that. V2B, right, vehicle to building. Similar to home, the vehicle powers a business. Right? And then the last one is a V2G, vehicle to grid. It's like excess solar generation that feeds into the grid. The vehicle can also send energy into the grid. So all of that, and anything else that you can imagine, just stick an acronym to it or a letter to it. V2X system enables BC Hydro customers to leverage their electric vehicles, right, to tap into additional benefits. The primary use cases that have received traction so far are as follows, right? Vehicle to grid, grid support locally at feeders or substations that need more power. Right now, the vehicles can provide more power. Vehicle to building, we can talk about peak load shaving when the building is peaking, or you want to save on demand charges or something like that. V2H is the most popular use case is to back up the house when there's a power outage, right? And then you can think of other uses like, emergency power for critical infrastructure during natural emergencies. Um, there's even business continuation during planned outages or planned maintenance if you need to take your power out, but you want to continue operating. So why is the V2G community excited? Well, electric vehicles provide grid services, right? And we admit that's still a few years away. The excitement in vehicle to grid is driven by the high rate of EV adoption, outpacing stationary storage. Even with the recent slowdown in the EV market, the forecasted gap between EV and stationary storage is growing. So in many markets, and including here in BC, the cumulative capacity of EV, the cumulative capacity of the storage is already many times of stationary storage. Right? The main chart is the latest forecast. The light blue is the forecast in 2019, and the darker blue is the latest forecast of the EV storage capacity. The purple on top is the stationary storage. So you can see, the blue relative to the purple is a lot higher. So the technical potential is definitely enticing for us, right? If you want to tap into storage, why not look at the storage in other vehicles rather than stationary storage, right? And like I said, while it's still early days with this technology, we need to prepare for it, right? The infrastructure, the grid will need several years to upgrade. The number of vehicles capable of bidirectional energy flow will continue to grow along with the number of V2G capable chargers. The medium and heavy duty vehicles sectors are equally active in announcing V2G ready vehicles. Right? And EV makers and customers will drive the pace of adoption of V2G. Right? Along with utilities, will develop the shared values. Right? BC Hydro will push for policies, safety, and standards to enable V2G. I'll just pause here for questions, if there are any.
Steve, it's hello. Thank you, Rob Safrata here. And one thing you mentioned is that the grid has to get ready, if you will, for this. Or what kinds of things does that mean? Because in the traditional supply, there's already plans for more transmission lines, upgrades to substations, those sorts of things. But as far as vehicle grid integration, what kind of things does the grid need to do to be able to accept that, for that at scale, for that to work at scale? Thank you.
Yeah, thanks, Rob. In the future, we were really looking into the future where we are at scale, as you mentioned. We imagine that the transactions will be a lot more dynamic and fluid. So we need to have good communications, two-way communications, to know what's going on, so that we can provide compensation back to the customer, for instance, or for them to know when they need to provide that service and when it's most valued, and when they can plan for things like that. So all of this requires a lot of communication, and certainly the way that the grid is set up now doesn't allow for this two-way dynamic real-time communication. So we have to do something about that. And there's a lot of safety considerations too, right? Where we want the grid to be safe. We want anyone participating in our programs to be safe. So that's why we need to do a lot of tests, and we may need to adopt new safety policies for our customers, or even contractors, or vendors, vendor community, to know how to do this safely. So there are certain things we need to put in place for that. I mean, those are just some examples of how we need to get our grid ready for that.
Thank you. I think that's it's very clear and very directed. And thank you.
Yeah, I was kind of along the same path. I just trying to understand. So on a vehicle to home, you would, there's a disconnect switch, right? So you don't power up the whole neighborhood because there's not enough batteries plugged in right now, right? With enough EVs. So you have to have a disconnect switch so you can power your home, but disconnect from the network. So right now it's simple. It's just a detector that says, well, hydro's got zero power. So it opens up the breaker. It allows a transfer switch to go run on battery. And then there's some communications internally telling to the vehicle to say, okay, I can discharge here. So you kind of answer partly that you need to have some communications with the grid better so that you can appreciate when you want to stay plugged in and power the grid and when you're just going to be an island or a vehicle to home only backup power, just more hydros out, an outage recovery. So I think I kind of answered with the first Robert's question there. I think so. But that's basically what we're talking about, right? We're just right now we're not there yet. All we can really do today is vehicle to home with a disconnect switch on with a transfer switch to between hydro and the car.
Yeah, no, and you know, I'm not a technical person. I'm not an electrical engineer, but what I can tell you is that our interconnection folks are very concerned about the timing of when power comes on and when batteries can start discharging. Right there, you want to have a bit of a delay just in case. And we want to sort of standardize that across the whole network so that if there are certain outages and we have crew working on the network, we know those are the safety features that are in place, right? We don't want different kinds of responses from everywhere. So those are the things that we need to work on. We need to work on certain standards and certain safety policies.
Yeah. Okay. So for currently, the vehicle to home with a disconnect switch is not against BC Hydro rules right now. So if you're aware or not.
No, I don't think it's against any rules at all.
Okay.
But in fact, it's we know there are many smart people out there who can make things work, right? And what we're trying to do is we're trying to come up with ways for everyone to participate in that, and not just people creating interesting stuff on a network.
Because I was getting a part two, and I think Steven was getting to that. Was that in the future with the communications, so that because I can plug in a vehicle and I'll program it to charge at night at the low rate, right? But then hydro wants the power now because it needs the extra boost into the grid, right? So that's the communication we need to work out, and then work out rates and everything that's involved. That's part of the problem that you have to work through right now. That's if I understand it correctly.
Yeah. Yes.
Okay.
And you know, the grid's gonna have different requirements. It's pretty dynamic, right? You know, some areas will have different values, right? But anyways, we can get into that later, or we can talk about it. You know, we can continue on this sort of discussion now if you want.
I think we can keep going with I think you're getting a couple of sides. I think you're going to get to there anyway. So thanks.
Yeah. So, you know, unlocking the benefits of bidirectional charging requires a knowledge of how the loads are connected and how to direct the energy flows, right? So I'll use this example of a vehicle connected to a house, which is connected to the grid, right? So we're going to spend a little bit of time on this graphics on the right here of this slide. So simple non-parallel power. So there's only one supply source at any given time. So case A is that, right? You know, we use it for charging the vehicle only, right? Energy flows from the grid to the house and then to the charger, to the EV, right? It's only one direction only, right? And that's, you know, right now that's categorized as a non-parallel power, simple non-parallel power. Now, case B, where when it's disconnected, when the house is disconnected from the grid, right? Maybe because there's an outage or some kind of local emergency. You know, the energy flows from the vehicle into the house to power the appliances and devices, right? It's still non-parallel right now because you're disconnected from the grid. And when the power is restored, the vehicle stops discharging into the house, right? So that's what we're considered sort of non-parallel. And then the other two cases are connected in parallel. So case C is when a customer, let's say a customer wants to do some peak shaving, for instance, right? They want to share, use both the grid and the vehicle to power the home. So two sources of energy, right? The grid is live, and so is the vehicle. And then case D, this is feeding power directly into the grid or through the house to the grid because you're participating in some utility programs, right? I mean, there's no reason to do this otherwise, right? If you're not participating in some kind of program, you're getting compensated for it, there's no reason for you to inject power into the grid. Right? So the types of equipment installed is also important, right? For case A, regular charger is adequate. There's no bidirectional charging. So this can be done easily with a qualified electrician. A permit may be required, and BC Hydro approval is definitely not required. Right? Yeah, a lot of people install their vehicle chargers, and they don't need approval from BC Hydro. And then for case B, now because you're doing a bidirectional charging, you're using the vehicle to charge the house, you have to upgrade to a bidirectional charger, and the vehicle has to be capable of doing bidirectional charging too. Additional considerations may include some kind of a dedicated circuit or appliance because you may not have the energy, the enough power from your vehicle to do the entire house, right? So you may need to plan for a sub panel, and usually more space more space and equipment around your panel. Right? A permit is going to be required, and BC Hydro is likely not required as long as the disconnect meets the technical requirements, right? The cost of this capability is obviously higher, right? Because the vehicle and the chargers need to be bidirectional. And it's important that the vehicle and the chargers are paired because there's not everything's plug and play. So with the vehicle, you may be limited to a certain type of chargers. Right? There may be grants available for the purchase of chargers. Yeah, I don't know exactly that, but I think there are funding available for chargers. Now for C, because you're doing the bidirectional, you have to upgrade to a bidirectional charger from a regular charger, and same with the vehicles, right? So I mean, this might result in some bill savings if there are different rates during different times of the day. But if the rates are all the same, then there won't be any bill savings. So there's all the considerations related to circuits and panels sort of applied to case, just like case B, right? But because you are doing parallel connection, BC Hydro approval is going to be required, most likely, right? Because there's just additional safety measures to be in place since the grid is expected to be live and operating in parallel with the battery discharge when the battery discharge happens. So the review process should be expedited if you don't have any kind of injection into the grid. So the review is conducted by power engineers and specialists in the interconnection department, right? We only have a few of these specialists, and that's why it takes time to get an answer back to you, whether, when and how you can do it. The BC Hydro review and approval will come at a cost to and some delay to your project when it's being reviewed. The additional safety measures may have a cost impact too, right? You may have to add other things to make sure that it's safe, right? That the BC Hydro review will tell you what's required. There will be BC Hydro programs to support this as long as you're providing services back to BC Hydro, like demand response, right? During our peak times when we need capacity and you're able to discharge your vehicle battery rather than grid, there will likely be some value back to you. In case D, again, this is where you're injecting power directly into the grid, right? So this is only applicable as part of a BC Hydro program. Otherwise, there's no value for the customer discharging into the grid. You have to upgrade to a bidirectional charger, and vehicles are required. And say, this is particularly, I guess, important for business customers, right? This can result in bill savings, right? If the timing coincides with the building's peak load, like for instance, if you're already peaking and you want to shave the peak with your vehicle, and this happens to be right at the same time that BC Hydro wants load reduction on our system, well, then that's going to definitely result in some bill savings for you, or at least you get earnings from that, right? And again, to do this, the BC Hydro approval is going to be required because now you're injecting power, right, which is considered a hazardous energy onto the grid. So, a review is required just to make sure to see how the system operates and what the limits are. And then communications have to be set up too, so that you or the customer that participates in the BC Hydro program will receive the dispatch signal from the BC Hydro system to inject power into the grid. The review process will be more comprehensive than in C, right? Because there's actual energy coming onto the grid. But we expect that we'll have pre-approved equipment lists to expedite and streamline this process in the future. Right now, we're just still testing everything, so we don't have that. And the BC Hydro review and approval again will come at a cost and some delay in your project while it's being reviewed. The additional safety measure may also have a cost impact too. So just that but there will likely be a BC Hydro program to provide some funding support if you're participating in the program. Right? And then depending on what the goal is for smart charging, planning and thoughts to the setup to minimize costs and time is required. So there was a lot in that slide. So are there any questions? No? Okay.
No, we're good. Thanks.
Okay, good. So I'll just move on. I mean, I want to talk about the past, present, and future of vehicle-to-grid pilots, right? So we'll step back and review the timeline for the vehicle-to-everything, right? The primary objective of these pilots and experiments that we're doing right now, it's all to enable a safe and efficient widespread deployment of V2X system, right? The strategic activities that we'll prioritize is to enhance the grid, support the energy transition, provide our customers with more choices and tools, right? And obviously to integrate new technologies because they're available, right? So we're working on developing this opportunity on multiple pathways, right? So let's talk about the past, present, and future pilots. In the past, we had a proof of concept 2 years ago at a lab in Surrey, right? We tested one bus. And then starting late August, we started a field trial at Lynch Bus Lines in Burnaby, where we had multiple buses, and then we were testing both vehicle to building and vehicle to grid. For the present, I mean, this is like 2026 to 2020, 2025 to 2026, right? We're going to continue to build on the vehicle to grid pilots involving buses and commercial vehicles. We want to increase the number of bidirectional charging locations to explore the value of movable assets. So that means sort of dispatching fleets to different locations depending on the needs, right? Sometimes there are more needs in one neighborhood or one region more than the other. And then we're going to update our integration processes and raise the profile of V2X. Right? We want to demonstrate this to our internal planners that vehicle to everything is a viable planning option. Then lastly, we expect light duty vehicles will be available next year to begin testing in the vehicle to home use cases. So we'll start planning now, including adding telematics to the test. So here's diving into a little more detail about the past projects. At PowerTech Labs about 2 years ago, right, we conducted our own sort of vehicle to grid proof of concept, right? So the project was our first on two fronts. It was the first commercial vehicle in Canada to discharge into an operating grid, right? Not just load banks. And then it was also the first interconnection field test for a bidirectional charger at BC Hydro. The partners for that project was Borg Warner and 60 kilowatt DC chargers. We had a Lion C-Class school bus from Quebec, Fermata energy integration software. So that's a software that brought everything together. The goals was to use an electric vehicle to feed grid assets, and that have a short duration capacity constraints, right? So we're just looking for places where we can use this where the peaks were only for a few hours and not for days. And then we also want to enable the resource using customer-facing programs, right? We weren't, BC Hydro wasn't looking to go and buy vehicles, fleets, right? We want to use fleets. We want to use vehicles that are already purchased by customers that may not be fully utilized. So the outcome, right? The technology proved that it worked. Performance was more stable at the high rate of discharge. When we tried to slow down the discharge, it didn't perform as well. For the model that we tested, the battery manufacturer limited the discharge between 40 and 70% state of charge, right? So that was that limited what we originally thought was the capability of the vehicle. We have winter data only because we only tested it in the winter time. The bus uses energy even when parked, right? So this was unexpected. There was a lot of back-end work to connect systems in the host of equipment. And of course, we still have the laws of physics to consider. Heat, degradation, conversion losses, it's all there. And I guess lastly, we saw a gap between the estimated performance and the actual performance. I guess going in, we all thought that the performance was going to be steady. When you discharge in DC, everything was going to be flat, but actually it isn't. There's lots of variations in there. We were focused. Sorry.
You mentioned the discharge, that there are problems when you're trying to do slower discharge rates. So what was the high discharge rate and what was the slower discharge rates?
When we try to discharge at 60 kilowatt, that's the rated discharge capacity for the charger. It was pretty steady. The performance was pretty good. But when we dial it down to 20 kilowatts, 15 kilowatt to extend the duration of the discharge for the battery, then it wasn't as steady. If we had set it at 20, we weren't getting 20. It was fluctuating, anywhere from 10 to like 25, 30 and stuff like that. So there's still some work to be done there.
Yeah.
See here. Our use case was to see if we can just address the code snap, right? Because we were looking at one particular substation that we thought that this application would fit well. So then, the V2G test simulated the peak shaving services required at a constrained substation on a peak day in the winter, right? And we chose the substation in the District of Hope because that's where we're currently implementing a non-wire solution to defer the need to upgrade the transformer. So And at that time, we had a customer who operated a large fleet of tour buses, right? At least half of the fleet sits idle during the winter months when the city touring activities are in less demand. Right? The vision is that these buses are electrified, and the idle buses could be parked near a constrained substation, connected, used as a stationary battery. And after the winter season, the buses would return to the normal operation. So this arrangement benefits both parties. I'm going to hop ahead to the next one. I think that the non-technical observations, anyways, the user experience, bi-directional interfaces are still or less intuitive based on the equipment that we're using. Right? For example, the charger defaults to charging when a user inserts the plug, right? But discharging requires a back-end programming and sequencing, such as stopping the charge session, resetting it to discharge, right? So most equipment isn't yet interchangeable with similar products on the market, right? So it's nowhere near plug and play, but we can make it work, right? The integration to end-to-end integration, right? Today, finding the right fit in partners is important because we want alignment and readiness, right? Even though we selected vendors who had prior experience working together in V2X projects, we discovered that there's still gaps that require custom integration and workarounds, right? Standards are being developed that will make it easier and more secured in the future. Auto OEMs are starting to team up with partners and partner with software and charging companies, right? So they lock each other into an ecosystem, right? Making it harder for BC Hydro to pick and choose who we want to work with. So we need to play with everyone. So we need to sort of compromise at times, right? Now, the experience from the lab gave us confidence to deploy at a customer site, right? So the V2G field trial at Lynch Bus Lines in Burnaby, BC, was initiated in December 2024, so that's last year, and it was implemented August 2025, right? What we did was build on the result of the proof of concept, and but with some things added, right? Unfortunately, we had to go to all new partners because the industry is still in that forming phase, right? And each partner that we had worked with exited for various reasons. So with the Lynch trial, we used some TELUS Power Green chargers, 40 kilowatt rating, BYD or Ride Canada buses. We use EV Gateway software. And then we also brought on Tessium IoT. It's for additional telematics and analytics, right? Most of these partners had prior experience working with each other or at least one partner. And we went with that because we didn't want to spend too much time in the learning how to work together and how to talk to each other. Right? Now the change in partnership was forced. For many reasons. We know that Lion had to close their factory. The Borg Warner chargers, the Borg Warner charger company decided to exit the charging manufacturing field. All kinds of stuff, and even the Fermata software was purchased by another company. Right? But with all new partners, right? We're still able to continue and to do the project and the pilot, and it's a reality of growing space, right? It's also an opportunity to work with new partners using the same framework, right? And I think it's a framework that is resilient here. The goals for this second project in the field trial was multiple use cases testing, vehicle to building and vehicle to grid at the same time. So we discharge into the building and try to offset the load in the building, and whatever that wasn't consumed by the building would flow into the grid. Right? There were multiple vehicles operating different schedules. we included the fleet customers' operational requirements, and then we this is also a good way to understand the field deployment requirements, right? It's, I mean, doing it in a lab and doing it in the field is very different. In terms of testing, we discharged into the building and grid beginning in late August, and it ended early November, right? So data is being assembled for analysis right now. There were about 8 weeks of charging and discharging according to a test schedule, right? The first 4 weeks, the buses were parked and acted as stationary storage to create a baseline. Then the later 4 weeks, the buses went on different routes and returned to base, then attempted to repeat the discharge requirements of the first 4 weeks. We couldn't catch the peak summer temperatures, but the weather was relatively warm at the beginning of the test period. I'll pause here for questions. Yeah.
What were, hi, Steve, Robert Safrata again. BC Hydro was very involved in the setup of this too. And, you know, it was different. So the line diagrams, those kind of things. Any comment there? Because, you know, BC Hydro was very involved, very helpful, very interested because it was different maybe. But what were some of the differences from just a normal charging setup, if you will, that were key? You talked a lot about safety in the future, communications. Maybe those weren't in this situation. It was so controlled. But anyway, I'll stop there and see what your thoughts are.
Well, I'm not sure it was that different from the lab. What we wanted to do was we wanted to increase the complexity a little bit, but not too much, right? So we went from 1 bus to 2 buses, 1 charger to 2. We try to have some kind of test scenario, sort of 4 hours, 6 hours, 8 hours kind of discharge. We did change seasons though, right? We went for a summer season rather than a winter season. And we wanted to get the direct customer feedback and how it affects his operation, right? So those were sort of the other changes. Yeah, I don't think technically in terms of how the chargers were connected and wired or communicating changed that much.
Okay, thank you.
Yeah, Steve. Yeah, I have a question, or yeah, I guess a question. In all the variables that you're talking about in the whole plan, I presume AI is used to help with all the managing all the variables. Is it? It's part of it.
No, not. We're not that sophisticated yet. So no AI. Yeah, no AI. What we think will be useful in the future is, you know, some type of optimization layer on layered on top of a couple of areas. One is for customer operations. They may choose to have certain priorities, and you know, if you have an optimization layer, it may help the customer operate more efficiently. You knowing that he has his goals prioritized in the AI or some kind of optimization engine will make sure that his goals are met first before participating in programs, for instance, right? And I can see a different layer of AI that sits on top of how BC Hydro may want to dispatch, the power or call for that service, depending on location, depending on sort of forecasted needs and things like that, right? So there's a different layer of that, and you balance the cost of this service against other resources that are available, right? So that you operate most efficiently and most cost effectively, right? So we talked about the past, the present, and then the future. We'll talk about the future. So in our press release, we signaled that we will stand up 4 charging hubs to test how we can move a fleet of vehicles to the hub to support that region. Right. So we anticipate that starting in 2026. So in addition to that, we anticipate that starting 2026, light-duty vehicles and chargers will be certified and deployed in Canada. So we're going to begin a small pilot with a limited number of vehicles and participants, maybe starting first with BC Hydro employees, using electric vehicles to respond to simulated outages and emergencies. Right? We'll work with fleet customers to pilot light-duty fleets discharging into buildings. We'll be collaborating with standards agencies to steer the market towards a plug-and-play capability. And to that end, there's quite an effort going on in Europe, and BC Hydro is joining this effort too, into this international group that's going to try to work on V2G standards, to develop or to test protocols for different use cases and different grid environments and different protocols. This is called Task 53. So if you're interested, you can just search up Task 53 on the internet and you can see what we're trying to do. Now, not all EVs have the V2X functionalities built in, but the technologies, as it evolves, the list of vehicle equipped with V2X features will continue to expand. Right? The ecosystem involves a few other groups other than vehicle and charger OEMs. Right? We see that government and regulators will own the policies and targets. Equipment and software solution providers from the automotive sector and power system suppliers for utilities, they must come together to figure out how to join the two ends, right? What the minimum safety functions for a car to navigate the roadway is nothing like the minimum safety function of a grid to provide energy to buildings and industries. Customers and utilities are both participants in the grid of the future, and we need to build that space, and especially the language and the currency. Right? We need research and insight to avoid driving into dead ends. Right? Now, stepping back from the pilot programs, and let's discuss the overall vision for vehicle to everything. Right? So, we talked about having a safe and efficient deployment of V2X systems, right? So namely that sort of vehicle to grid, vehicle to building, vehicle to load, vehicle to home, maybe even microgrid or something like that, right? It's to support the BC Hydro's sort of customers' electric transportation transition, right? And still provide the electric grid with system benefits from the vehicles. Now, if we want to drill down further, right? And so this is what I would say to in other meetings to utility. Right, I would just tell them that mass deployment of V2X is still a few years away, but based on our current learnings, there are things that we should consider when planning a V2X project, right? Or even for you that are sitting in this room, if you're thinking about doing your own, vehicle to home or vehicle to something, vehicle to load, the choices of vehicles, chargers, controllers, even contractors and engineers are limited. Right, and each one offers something different, but they're not easily swappable, right? The value of vehicle to grid is dynamic, and it depends on the location and the time of the year, right? Value is higher in areas where existing capacity to add new loads is limited, right? for instance, if somebody wants to connect to one of our feeder, but the feeder's fully loaded and they can't connect to it, well, we can possibly open up some capacity by using vehicle to grid during times when that feeder is at its peak, because it's not at its capacity all the time. It's only during certain times, certain hours, right? So to do that, if you use a vehicle to grid, you might be able to open up the capacity for new customers to connect, right? Now, also in areas of higher frequency of outages, I can see that there's certainly more value for vehicle to home or vehicle to building, right? So definitely include the resilient value in your calculations. Many customers are still unaware of V2X, and so there's lots of potential to change how they view and participate in the electric system, right? Because the technology is new and the V2X features are available on premium products only, there is a higher cost to be early adopters. And we feel it's important to socialize and establish the value of this flexible storage opportunity. So we need customers to participate in grid programs in order to realize the value for the grid, right? So current demand response programs provide pricing signals for the market. Again, there's value in resiliency. There's more efficient grid utilization across all vehicle classes, right? I think that's a benefit that we need to look into. And obviously a higher utilization, efficient use of storage capabilities, right? A lot of times storage is, or even backup systems, diesel backup systems are only used when there is an outage, right? And doesn't happen that often, but you still have to run it once a year. You still have to do all kinds of inspections. Whereas I feel if you're able to tap into vehicle storage and use that as your backup system, you'll be using that asset a lot more, right? And therefore it's more effective use of your investment. Right, that's the end of my presentation.
Excellent. I'm going to hog it for a little bit.
What?
Normally I don't, but I'm excited about V2G. If you can go back to one of the earlier slides where you showed the sort of the outlook for existing EV battery or EV batteries and the stationary utility batteries. I just wanted to point out that if we use 10 to 60% of the EV batteries instead of utility batteries, you now have batteries doing dual function. You don't have to mine the batteries. You don't have to produce the batteries. The batteries working when the EV's not being driven, making EV drivers money. Like the opportunity is phenomenal. So, and if you're a homeowner, you can spend $20,000 and put a 10 kilowatt battery as a power wall for backups and time of use savings and stuff. Or you can put the extra $20,000 into an electric vehicle where you have 60 to 200 kilowatts of battery.
Yeah.
It's just works so well. Anyways, I've got others, but I'll do them later. Anybody online? Stephen?
Thank you very much. It's a fascinating and exciting talk. I'm really enthusiastic about this. I was wondering if you can tell us a little bit more about the potential. So in terms of like market penetration of EVs, if 10% of drivers have EVs, how much can we bring down like the cost of infrastructure or the number of gigawatts that we need at peak times? And once we get to 50%, how much will we benefit and so on?
Yeah, no, thanks for that question. We're going through that study right now, or we're trying to model it right now, and we're working with a company called Asset Market, and so we're looking at different adoption scenarios, right? And these adoption scenarios are driven by sort of government mandates too, right? And whenever these mandates change, then we have to make adjustments to the model. But based on what we know and how we can look at sort of ICBC registration data and trends and things like that, we're going to try to model how many EVs are going to be in the market in 5 years, 10 years, 15 years, and so on, right? And then at the same time, we're also monitoring all the vehicle manufacturers in the rate that they are announcing V2G capable models, right? And then so we'll apply that to the adoption rate so that we can sort of estimate how many vehicles are going to have this feature, and then we and so we're going through that now, and we also look at some of our past G conservation programs in terms of customer participation, right? Eligible customers versus how many actually participate. And then we're going to try to map that on top of the vehicles to come up with a technical potential as to how much we could do. It's not, but there's another element to that. It's not all about the size of batteries. It's about the chargers that customers may choose to purchase, right? For instance, I was earlier talked about the different chargers in our pilots. We had a 60 kilowatt charger, and then later on we had a 40 kilowatt chargers. Well, these chargers limit how much you can discharge, right? So depending on whether customers adopt DC fast chargers and then what ratings they adopt will also determine what that capacity is, right? So we're going to try it again. We're going to look at sales data and things like that to see what are people buying, and then we can estimate the pairing of certain vehicle sizes to certain chargers, and then try to figure out what that capacity is, and then come up with a forecast of what we think is available. So in all that, I'm sort of explaining to you that we're trying to work on this model and trying to develop an estimate of it, and I haven't even gotten to the value portion of it, but we're trying to figure out what that technical potential is first, and then we can figure out what that value is.
Great, thank you.
Robert, you have anything?
Do you mean this, Robert?
Yes.
Thank you. Well, again, this is very comprehensive. I think you're getting an amazing overview and summary, and I've certainly enjoyed listening to the development and seeing the thoughts. And the other thing I would add is the way, another way of looking at it is because, there are chargers at 80 kilowatts, 120, you can change that whatever you want. So, BC Hydro, as I understand, has goals for demand response, maybe an extra 400 or 500 megawatts in the next 5 years or so. And so another way of doing it is, well, okay, therefore, what's needed are so many residential, cars dispatching at a certain rate, so many buses, so many trucks, different rates, different times of day, and really so that either the incentives or whatever dictate whether it's a 10, 20, 40, 80 kilowatt discharge or more and times a day. Some companies that I'm aware of would change their schedule slightly to take advantage of being more available to be more valuable. to the utility, and so that they can therefore afford these vehicles. There's all that. So the work you're doing with asset market is really helpful. And the other way of looking at it is, well, what do we want? What do we want, and what's it going to take to get it? And finding those folks, those companies, those fleets, or those incentives. I think 400 or 500 megawatts is around, depending on the mix, it's anywhere from 7 to 10,000 vehicles. And it sounds like a lot, but it's not.
Last I looked, we had 3.9 million vehicles in British Columbia.
Yeah, and the adoption, I guess from BC Hydro's point of view, the adoption of those electric vehicles didn't require BC Hydro to provide incentives for them, right? People went out and got them, but now that they have them, I think it's a great opportunity for other uses of them, and we see one of the benefit is supporting the grid. Right.
Steve, where it's gone? Oh, I know. Are you, as BC Hydro, working with other hydro providers across the country doing something similar to what you're doing? And if so, are people cooperating and building off each other's ideas?
Yeah, yes, they are. Yeah, or yes, we are. I've been talking to other utilities, and they are also working on a roadmap or a playbook on how to take advantage of this, or how to determine what that value is, so that they can make their plans. And I think sharing what we're working on with other utilities, and they're sharing with us, I think that's going to be great. And along with Robert, we're trying to get other players in the game across Canada, right? And Robert can tell you more about it, I guess, when he's making his presentation about his pan-Canadian efforts. But I feel fortunate that I've been able to do a few pilots, and whereas other provinces haven't done that. But when I get a chance to talk to them, I always tell them that don't do what I've done already, go beyond, right? Just use what I have already done and save yourself lots of work, right? And because I think we need lots more activities and these type of projects in Canada. And and my my push for that is a little selfish, because I find that if we can get more projects like this in Canada, then we will have a stronger voice when we're asking the auto manufacturers to provide features that are more suited for the Canadian climate or environment, or our voltages, or everything, or CSA standards.
Yeah, well, one of the questions I was going to ask, and you answered it, was whether you're working with different companies and governments and oversight bodies around the world to create standardization, and you are, which is excellent. With that standardization, China in the last few years has really ballooned their battery swap volume and capabilities. Have you thought about the implications of battery swaps? Because I think that can lessen the load demand on the grid and provide this battery storage capability for you. And I think there's a lot of win-wins. It's still negative on battery swap for a few reasons, but boy, do I see a lot of advantages to it.
I, I'm quite optimistic on battery storage or energy storage, and for me, it doesn't really matter in what form they come in. I think that if I were to look at how it can benefit the grid, a distributed um, energy, distributed energy storage resources, across the entire grid is going to be great for BC Hydro, right? So if it comes in forms of swapped out battery that still had some capacity and that can plug directly into a grid and provide support, I think that's also a nice feature, right? Yeah, who knows? In the future, maybe we'll carry around cell phones that have huge battery capacities, and we can all easily share it and plug in and distribute energy.
Yeah, the battery swap I'm talking about is instead of charging your battery at a charging station in China, they have a few thousand buildings that you drive into, and a minute later you drive out with a full battery. They've removed the discharge battery, put in a charged battery, and then they can charge the battery slower.
Yeah, no, I understand that, but what you're talking about is benefits of driving, right? Where you're doing it for driving purposes, whereas for me, I'm always looking at what are other uses of energy storage other than using it for driving, and if there are if you have a battery swapping service, it sounds like you have more batteries than you have cars, right?
That's correct.
And not all, and not
Like
all of them are going to be fully drained. So I would like to tap into that, idle capacity.
Yeah. So I was thinking the companies that are providing the battery swap fueling are the companies BC Hydro wants to make agreements with. So now you're not dealing with a small 60 kilowatt battery. You're dealing with 10,000 60 watt batteries.
Yeah. Or any car dealerships, right? A bunch of cars sitting around, not doing anything, certainly not being driven, right? But if they have, enough charge in their vehicles, I'd like to tap into that. Or let's say the park and fly parking lot at YVR. I would love to tap into that if that parking lot is full of electric vehicles.
And
one thing. Another question.
It's Robert. Just if I may though, to Steve, you mentioned and then you didn't use the word, but the interoperability, which if you can say that 3 times quickly, I'll give you $5. That's key too. That's a key item, and congratulations on joining Task 53. That's their goal around the world. So that I think one of the things that will slow this down in residential, in homes, if I buy a GM car and I need to buy a GM energy bidirectional charger and software, but then X years later I buy a Volvo, that thing on my wall is no good. And that's the kind of thing that would slow adoption, I believe. And so the interoperability is really key as one of the functions for this to proceed.
Stephen, were you going to say something?
Yeah. It's easier to say than interoperability.
Resiliency.
Yeah, I like that.
I have another question. I'm wondering, you mentioned that there's a sort of consortium of countries that are working on this, and I was wondering if there's any country or jurisdiction that's particularly further ahead than anybody else. Is there any place we can look to where they've tested some of these out and been able to look at it at larger scale, or is everybody still at this very early stage?
I think if you're interested in DC, like, DC, the US is definitely ahead. If you're looking at AC, then I would look to the Netherlands, right? They're quite ahead from the AC perspective. Yeah. So we don't know. We don't know. I certainly don't know who's going to win out, whether AC or DC. But there's just more DC equipment available for us here in Canada now. And if we wanted to learn about it, then we start with DC, right? If we sit and wait for the world to tell us whether it's going to be AC or DC, we'll be too late.
And is there any place where regular electricity customers can already plug into the grid and do the vehicle to grid charging, or is it still just being tested?
In BC, we're still testing it. I mean, we've heard of customers who have done it, but obviously not. It wasn't big enough for us to actually notice it on our grid. But if we start encouraging it, then we'll see more. And so that's why we need to have certain safety requirements in place, right? So if we learn more about how to manage this.
Can you?
Sorry, I actually meant other countries.
Yeah.
I'm wondering if there are other countries where they might already be doing this.
Yeah, like the Netherlands are quite ahead in doing this. Yeah.
And I think to your comment, you were quite interested in V2H earlier. If you look at GM Energy, you'll see a pretty slick ad. You can go to your dealer, buy the bidirectional vehicle. They'll walk you over to the wall where you can buy their bidirectional charger, and maybe if you buy the premium one, it comes with some stationary storage. Then on the website, you can click on a button for installation, and there's a group that coordinates that all over North America or United States. So you can get a trained electrician to come and install it all, and you've got V2H. So it's just it's dialed in. So that's one of the best examples I've seen to date on the residential V2H. Not available in Canada at the moment.
Yeah, Robert, I think that's a good thing to tell everyone, is that most of the vehicle manufacturers have not enabled this feature in Canada yet, although we think they're actually enabled because we don't have enough chargers to actually test them.
Mm-hmm.
Yeah.
Mm-hmm.
But I do have one that I want to test. We'll see how it goes. Next year.
Can you advance the slide
Sure. Which one do you want to look at?
to number 6? Yeah.
This one here.
Yeah. So just looking at scenario D for people who aren't thinking or haven't really thought through this vehicle to grid. When you make an agreement with the utility, you say, you give them the rules. You want a minimum percent charge in your battery at all times so that you can get to work or whatever it is you're going to do. And if tomorrow morning you're going on a big trip, you can opt out and have your battery 100% full in the morning for your trip. So it's should be quite versatile. And the new batteries coming out, the single crystal electrode lithium.
This goes the same with our energy storage program right now in market. What we are looking for is for the customer to nominate a small portion of their battery for us, so for the grid use. So, let's say you have a battery and, you nominate 20% of that to the utilities, and you still have 80% to use. And most people don't use 80% of the battery on a daily basis anyways, right? So, you have lots of margin, lots of safety. And I would imagine that, if we're doing similar kind of a program, but, instead of a stationary storage, you use a car's storage. I would encourage a customer to sort of figure out how much they normally use, and then they can comfortably nominate what they want to nominate and earn some rewards back.
And with something like the single crystal electrode lithium battery, you're going to get 3 million, 5 million kilometers of driving out of it. Your car is going to fall apart for your batteries. So you may as well.
What battery is this? Single crystal? What is this?
Single crystal electrode lithium ion batteries. Jeff Don out of Halifax is his technology, and they're on the road. Well, they're in products already. They're probably in a couple of Chinese electric vehicle making models by now as well. So they'll very, very soon be in batteries or in EVs.
In Canada?
They'll be in China first.
Yeah.
But yeah, they will make their way into all EVs. Well, shouldn't say that. You're going to buy different battery types for different reasons. So,
yeah.
For the future pilots, my last question, you mentioned the light EVs. What makes and models are on your horizon that might be workable for you, or have you gotten that far?
Well, I'm looking at the Ford F-150, the best-selling EV trucks are out there, and they're supposed to be, V2G capable, but there isn't a charger partner in Canada yet, right? If we're able to find a way to tap into that, I think that would be something that would be very interesting. The new Kias have such large batteries that I would love to tap into those, the EV9 especially. I believe the Hyundais, the Ioniqs, are also supposedly capable, and if what I heard is true, that the Teslas also have this built-in capability, but they just haven't marketed it yet. I think that would be very interesting to me. And what I'm just doing is I'm just picking out the most popular vehicles there are, because that's when you can get to the highest number as quickly as possible in terms of technical capability, right?
So Steve, just I'm from a mechanical background, but if I'm understanding this on a more grandiose scale, is that particularly on your parallel side? So say we needed 2,000. BC Hydro needs to add 2,000 megawatts of generating capacity for whatever reason, right? As the load increases. But,
sure.
But the beauty is that the 2,000 is meant to cover your peak periods. Now you're saying is that with these battery connects, you may only need to install 1,000 instead, and let the other 1,000 be covered by all the batteries connected instead, thus saving BC Hydro some cash, some capital investment, and in the process, people who are connected will also be able to generate some revenue for the vehicle they own. Is that about the gist of what you've been saying all along?
Yeah, no, exactly.
Okay.
Yeah, because the grid. I mean, there are peak times only, right? And these peak times don't last that long, right?
Yeah, because I did the study a while ago, and just gasoline only was BC Hydro, if you want everybody stopped driving gasoline vehicles and switched over to EVs, and drove the same number of kilometers, you would still, you're looking, I think BC Hydro's estimate was 1,600 megawatts of additional capacity needed to be created, right? I'm around, I was about to sell 15 to 17. So depending on your assumptions. So yeah, so that's why, so this is an intriguing thought. I hadn't considered this, that by using the batteries, you don't have to build as much generating capacity. You let the batteries take care of all your peaks for you and then you carry on from there. So you can stretch out your capital costs in terms of your infrastructure build out and generating capacity. Right.
Yeah. It's more efficient use of whatever infrastructure we already have, right?
Yeah.
Okay. Unless there's another burning question, I think we should wrap up. Thank you very much, Steve. That was very informative, very interesting. And for those who don't know Robert, who's also online here, he's the gentleman who's going to be presenting to us next month. And he's the lead of a private partnership that Steve talked about where they're doing V2G already.
Awesome.
Thank you.
Great. All right.
Thank you very much.
Thanks, Doug.
Looking forward to next month.